Just unmute yourself if you wouldn't.
Hello.
Thank you. Hey, so I'm going to continue over the schedule if you don't mind. You can feel free to prep yourself. We've got Maya here at 10:30. At 11, we got a break, and Mike and I will chill out and probably BS for a second. And then Mike's going to welcome the very, very wonderfully vulgar at times Charity Majors. Love a great mouthful of curse words from a talk once in a while. And once in a while you get that, and I appreciate it. And then Mike is going to host Best of Ignite Talks, which there are a lot of great 5-minute Ignite Talks out there in the world. And Mike's going to present a few of them, and you'll all be able to check them out. So first of all, Maya, let's give you a chance to introduce yourself. How are you, and where are you calling in from?
Sure, I'm in San Francisco, calling in from my place.
Awesome.
Sorry?
I said awesome. Thank you so much for being part.
Where are you?
I am in New York City, where it's late. It's so weird. But you know, I'm glad to be here and to be able to do something like this with yourself. I'm very, very lucky that we are a part of kind of a community that, you know, we got a lot to talk about, and we tend to talk a lot. But if we can take all that talking and produce it into something that's beneficial to someone other than ourselves or the places that we work for, then I think, you know, me and you being part of the big Microsoft umbrella, we can feel a little bit better about ourselves. So for you and the rest of my my Microsoft family, I say thank you for being, in a way, whether it's GitHub, Microsoft, or whatever we're doing, we're all kind of been dealing with it in our own way all over the country. And so thanks for giving this talk about software.
Yeah, thank you for volunteering and hosting. I love loving the music that you had.
Thanks. I try. So I'm gonna give the room to you, if you will, the virtual room, and we'll hopefully get some questions, and we'll talk a little bit in a few minutes. All right. So please enjoy.
Sounds good. Great. So it sounds like I will just get started. So today we'll be talking about software supply chain vulnerabilities. And they are real. That's the whole point of this talk. They are actually things that we have seen happen in the wild and that can exist. So I'm Maya. I'm a product manager at GitHub. I work on software supply chain security. No wonder I'm talking about this topic right now. It's something I find really interesting and really exciting, and because it's such a big real threat that we know we need to go solve in the industry. So we'll be covering software supply chain vulnerabilities. We'll first talk about what a software supply chain is. If you haven't heard that term before or unfamiliar with that term, we'll dive right in and cover specific compromises that we've seen, and we'll cover common kinds of attacks and when they're likely to happen, and how and why these attacks are happening. And we'll close up by discussing what, as developers, you can do today to avoid these kinds of situations. So let's get started. So the reality is today that it's extremely common to not actually really know what's running in your environment, right, as a developer. A large amount of code that a typical organization uses is open source. I've heard anything from 80% to more than 99%, and you don't necessarily know what that actually includes. So though you decide to pull in dependency A for your project, it's possible that A has other dependencies B and C, known as transitive dependencies, and sometimes you don't even know that you have a dependency at all. So you're faced with a situation where you don't actually know what you're running in your environment. And you just can't verify all of that code. It's simply impossible today. So where we've landed as an industry so far is that you need to be able to get some information and manage risk for the dependencies that you do have in your code and the potential vulnerabilities that these dependencies are introducing. And that's where the concept of this software supply chain comes into play, just like you might have a hardware supply chain or a food supply chain, understanding what ends up in that end product that you consume. Software dependencies are pervasive. It's normal for your projects to use hundreds or even thousands of open source dependencies. If one of these dependencies has a vulnerability, then chances are that you have a vulnerability as well. Being able to leverage the work of thousands of open source developers means also that thousands of strangers effectively have commit access to your production code. So an innocent mistake or a malicious attack to your supply chain will affect you deeply. And So to kind of think about what that really means, a software supply chain is then anything that you depend on to deliver your product, right? For a pharmaceutical company, it's the provenance and the verification of ingredients that go into each drug to ensure high quality. For a chocolate bar that you buy at the store, it's the list of ingredients and some information on nutritional contents, maybe organic ingredients and production facilities that you might have in the package. If it doesn't produce in a facility that doesn't, process peanuts, whatever it happens to be. So then a software supply chain is everything that goes into your software and where it comes from, who wrote it, when it was contributed, how it's been reviewed, including reviews for security issues, any known vulnerabilities, supported versions, license information, if that's applicable, just everything. It's everything that you could want to know about the software that you're running to help you determine your risk profile. A software supply chain is anything that goes into or affects your code from development through your CI/CD pipeline until it gets deployed into production. Now, when you talk about dependencies, as alluding to earlier, what's scary isn't as much as what you're developing internally, because hopefully you have some controls to say prevent developers from pushing code from their bathtub, or maybe not during today's times, or you restricted who has super admin rights in your environment. But what's scary with open source code is that you are allowing open source developers to the code that you're allowing your developers to pull in from open source. You don't know what's actually there, right? Because open source is easy for developers, it means it's also easy for attackers. I don't want to scare you. I want you to keep using open source code and contributing to it and working on it. I just want you to do it thoughtfully from a security point of view. What's attractive from an attacker in a supply chain attack is that a single compromise vector can actually give them access to multiple targets. So what developers are purposefully pulling into their code isn't, actually in reality as closely examined as, say, like network intrusions into your environment. So it's a very attractive way of attacking your environment. Okay, so you might have heard security attacks broken down into kind of three components: who the attacker is, like a script kiddie or a competitor or a nation state, how the attack is conducted, and what the attack is attempting to do. A supply chain attack in and of itself isn't usually the end goal, right? It's usually a step towards something else. And unfortunately, or fortunately, almost anyone can conduct such an attack. So instead of focusing on the who, we'll focus on the how, which is what happens to infiltrate your supply chain, and the what the attacker is actually trying to get at. There are a couple of different methods to attack your supply chain, the how. Inserting malicious code directly into a dependency. This could be a purposeful backdoor, known malware, or a known vulnerability, or even introducing a new dependency. This is like walking through the front door to introduce a backdoor. Compromising a build tool, infrastructure tool, or another piece of the CI/CD development pipeline, which again could be yet another supply chain attack. So a supply chain attack for a supply chain attack. It can get a bit meta. Compromising signing keys to make it seem like an unknown package came from a known trusted source, right? Because who verifies those signatures anyways? Compromising a package manager or any kind of other distribution tool for packages to affect several artifacts being distributed in the supply chain. It could be a website used for software updates, like an update server. It could be anything. Compromised vulnerability reporting. So this is basically man in the middling or man on the personing, or person in the middling, getting myself confused, like a security at reporting address, getting into bug reports, for example, on a bug bounty site, or even getting on a fix or disclosure mailing list for a project. That would allow a malicious actor to find out about a known vulnerability before it's widely announced and patched. Sometimes you've heard of this term called bug door. And the idea is you know about a bug and you can use it as a backdoor, and then you just choose not to fix it. So you can keep using it as a bug door into an environment. Account takeover of a maintainer. So this could be to fake commits, and depending on how signing keys are managed, this might be one and the same attack if they can get access to those keys as well. In addition to compromising what a maintainer can publish without even going that far, this could also include something like compromising a maintainer's email, again, to get something like the security at bug reports. A project takeover, especially of an abandoned project. Accidental attacks like typosquatting to get users to accidentally pull in your project as a dependency when they mistype something. And deletion, just getting rid of whatever that dependency or that piece of code was. And these have a few different aims or goals. Spoiler alert, as like other attacks in security, the ultimate motivation is almost always money. So introducing a backdoor into your environment, this might be targeted for users of only a particular piece of software, operating system, or region, or it might just be a wide swath to see what they can get access to. introducing malware, for example, to select login information. But really the easiest way to make malware, to make money these days is from cryptocurrency mining. So abusing any extra compute to mine the trendy currency of the day, or setting up a botnet also falls in this spot. And lastly, service disruption, right? This could be, for example, taking a service offline. So let's get into some of the examples, because this is the part that I find really, really fascinating here. So first, let's look at EventStream. This is probably the one that, if you've heard of a supply chain attack, you've probably heard of EventStream. It's a widely used Node.js library available via NPM. And when I say widely used, I'm talking 2 million plus weekly downloads. So what happened? In the fall of 2018, a user, Right9 Control, volunteered to take over EventStream on GitHub. Again, it's a widely used package, but not super well supported. So the author welcomed the extra help and even gave the newcomer publishing rights. I want to emphasize that the author is not to blame here, because we should have better ways to support these developers and also verify trust of our ecosystem. The author literally wrote in a GitHub issue, he emailed me and he said he wanted to maintain the module, so I gave it to him. I don't get anything from maintaining this module, and I don't even use it anymore, and I haven't for years. So very much in the unsupported category. On September 9th, Right9 Control added a new dependency to EventStream, flat map stream. And then a week later, on September 16th, they rewrote the code to no longer require that dependency and tried to remove it. That change was made in the code base, but wasn't actually pushed through to where the library is being hosted on NPM. And then on October 5th, another user, HugeGlass, added malware to FlatMapStream. So then anyone who would have used EventStream and pulled in the latest version of FlatMapStream would receive that malware. This was discovered in late November 2018, meaning the dependency and malware were running for almost 2 months before it was discovered. Now, fortunately, this wasn't actually that bad. It was bad that we didn't find it sooner, but this was extremely targeted. The malware looked to see if the host was a developer for a particular kind of cryptocurrency wallet, the Dash Copay wallet. And if the host was a developer for that piece of software, it inserted additional code to be distributed into the Dash Copay wallet. The code would scan user deposits to see if their Bitcoin or Bitcoin Cash deposits were over a certain amount. And if so, captured passwords and sent those to a remote address. The malware did, in fact, make it into a handful of releases of Dash Copay. So this was a successful insertion into the supply chain. There's no information that I could find as to whether or not they were actually able to get any Bitcoin from this attack. Next up, eslint. I love this example as it's again a software supply chain attack to try to make more software supply chain attacks happen. So a meta software supply chain attack. In the morning of July 12th, 2018, new versions of 2 of the components of eslint were published on NPM. Within an hour of publication, a user filed a bug against the project, and the malicious packages were unpublished. All told, those packages were up for less than 4 hours, and a few hours later, fully remediated with new uncompromised versions being published. So what actually happened in that 4-hour time frame when those packages were up, or how did the malicious packages get published? Well, the maintainer of eslint reused their password elsewhere and didn't have 2FA enabled. So attackers used credential stuffing to generate auth tokens for their account and start publishing new packages. The malicious versions of eslint would try to connect to and download and execute code found on pastebin that captured the npm RC file, which is typically where npm auth tokens for publishing packages are stored. So the goal here in compromising one npm package is that they were hoping to get credentials for lots more npm packages that they could then go compromise. Since this malware was trying to capture npm credentials, the response to this issue had to be wider than just a single package, right? And in fact, npm took action to revoke all the access tokens generated before the incident. That includes private packages. So if you think of the impact of that, that's huge. That's a lot of potential users affected by the cleanup of a single incident, even though the postmortem determined that only a very small number of packages and users were affected. So as much as I want you to also automate and automatically update all your dependencies, this is a great example of where this would actually have been bad. So for the downstream packages, you should make it as easy as possible to upgrade. But ideally, a human is still in the loop, especially if you're publishing a new version. Using a lock file is another great way of forcing the explicit acknowledgement of any new versions of a dependency that you're using. Next up, Kingslayer. No, I'm not talking about Jaime Lannister. This is an interesting one. This supply chain attack, dubbed Kingslayer, was presented at RSA without initially disclosing which software had been attacked. Brian Krebs then wrote a piece shortly afterwards to draw attention to the fact that there wasn't a sufficient disclosure, identifying the software as EVlog, which is produced by Altair Technologies. This is also one of the OG supply chain attacks, right? This happened way back in March 2015. On March 31st, 2015, a website used for distributing the Windows log management software, EVlog, was compromised, with attackers publishing new signed software with the Kingslayer backdoor in that software. A few days later, on April 9th, so it's literally like 10 days later, the attackers also compromised the update website so that versions that were updating themselves automatically would also update and pull in the compromised software version. This is suspected of being an attack conducted by an APT. I couldn't easily find details on what the Kingslayer malware did, but it seems like it was meant to steal some sort of credentials. So although the vendor actually found the issue and fixed it on April 26th of 2015, so again, all of this taking place within a month and being fixed within a month with a republished version, they didn't do a very good job here in terms of incident response and communications. So a defense contractor kept running the backdoored software until it was discovered in August of 2016. So that's more than a year later, before they went ahead and found and identified other parties that were also at risk in order to help them remediate. According to the talk at RSA, based on which IPs were contacting the update server, the victims could have included, so not confirmed, but could have included 5 defense contractors, 4 telcos, more than 10 military organizations, 24 banks or other financial institutions, and a handful of other Fortune 500 companies. So a huge potential attack for some of these large conglomerates, large organizations. All right, next up, Webmin. Webmin is a web app for managing Unix servers like those running Linux or OpenBSD. In August of 2019, it was revealed by a researcher at DEF CON that Webmin had a backdoor allowing for unauthenticated remote code execution. This allowed, in some earlier versions, any unauthenticated access, and in later versions, only unauthenticated access if the installer had changed the authentication to allow for users with expired passwords to then reset their password. So it was a flag that they needed to enable. The attackers actually enabled that flag by default. This was disclosed as a researcher as a 0-day without previously notifying the project of the vulnerability. The backdoor was inserted as part of the build process. Interestingly, the attackers only compromised some of the distribution with valid Webmin and usermin code on GitHub, but backdoor packages only on SourceForge. So it's not clear to me exactly what part of the build process compromised, and the maintainers didn't clarify how this could have happened. This remained for multiple versions of Webmin, with backdoor versions being distributed for over a year. Likely the build servers were first compromised in April 2018. What's really sad here is that the maintainers even moved to a new build infrastructure in September of 2018 and just copied over the backups that had the backdoor in it. So instead of rebuilding from source, which is a great practice to try here, please don't copy over your malware and keep distributing it. Thankfully, they were able to fix the issue by, in fact, rebuilding from source. And that is a lesson here. Building from checked in source code on GitHub, not a local directory that you're using. Another great example here, Docker 123321. In May of 2018, several malicious images were discovered on Docker Hub. Cromtech, which is the research company that found this, found 17 images with plain names like Docker 123321, and those contain malware. The Docker 123321 registry was created in May of 2017, so a year earlier, and malware was added in the summer of 2017. The community was actually pretty good at discovering this and identifying these issues, with complaints made to Docker Hub in the fall of 2017. However, nothing actually happened, and these images stayed up, publishing even new versions, including the same malware. Fortinet was able to link these images to a cryptocurrency mining botnet definitively in early May of 2018, and then Docker Hub promptly removed the images. Nonetheless, in that time period, in that 1-year time period when this was online, the 17 images in the registry were downloaded over 5 million times. That malware that they contained was for mining cryptocurrency locally, in this case Monero, and then sending it to a remote server. It's estimated that over $90,000 worth of Monero was mined by these images in that time period. So I was a little bit surprised by that. I was like, 5 million downloads, that's terrible. And then I was like, oh, $90,000 of Monero, that doesn't seem like that much. This was basically like a toy library. Like they were just depending on users testing random images and like messing around to see what they could do, or accidentally downloading them. So I think for an accidental download, taking home a $90K paycheck is pretty good. And if anything, this just gives attackers an idea of how quickly their malware could be detected and how it'd be handled. This was a great test example if I was an attacker to see what I could get away with and over how much time. And lastly, LeftPad. This made quite the headlines, and you might not think of this as a supply chain attack, and you probably heard of it. But I want to point out that it is still service disruption. So on March 11th, 2016, a developer who maintained a small library called Kik, K-I-K, on NPM was approached by Kik.com, which is the Canadian messaging app, to change the name of his package. He refused, and they didn't want to pay the amount that he proposed to take over that name. A week later, on March 18th, Kik.com's lawyers went to NPM, who agreed that this could create confusion and handed the Kik library name over to Kik.com. Just a few days later, on March 20th, the developer sent an angry email to NPM about this decision. He wrote, I think I have the right of deleting all my stuff. And that's exactly what he did, removing 273 of his packages. On March 22nd, millions of developers experienced exactly that when their packages would no longer run because they were missing a LeftPad library, which most of them didn't even know they needed, that the same developer had owned and deleted. It's a tiny function that you could write yourself, 11 lines of code to add characters at the beginning of a string, but so many other packages depend on that to be able to function. 2 hours later, NPM made the controversial decision to republish the deleted package. This wasn't a malicious attacker, like I said, and so it's weird to think about this as a supply chain attack, but I do. The developer himself was mad. I don't think he understood the impact this would have. It's more about just showing how interconnected all of our software is and how few know the dependencies that they truly depend on, right? Like the developer didn't know it was going to have the effect that it did. Users didn't know that they were using this package. It caused major service disruption, right? That's still something that I would be worried about happening in my environment. So looking at some of these together, right? I only picked 6 attacks. This isn't a complete overview, but more of a reminder in case you didn't realize, like we've been seeing these attacks for a long time. Since at least 2015, supply chain attacks that affect server software have been occurring in our world. And there's a lot more examples that I could have listed. This is just 6 of the examples that I chose to focus on today. So now that I've sufficiently scared you all and told the great stories that I find very interesting, what should we be doing, right? As much as we want to think that we're all going to be dealing with the next super scary, crazy supply chain compromise, if you have a software supply chain security issue, it's probably your fault. Did you forget to update your dependencies again? This is about basic hygiene, right? Reviewing and patching your dependencies. Boring, super boring, but that's it, right? White Source found in the latest State of Open Source Vulnerabilities report that 85% of open source vulnerabilities have a fix available at disclosure. All you need to do is apply them. And that's why this is boring advice that people don't want to follow. It's like brushing your teeth or washing your hands for 20 seconds, right? We all know that we should be doing this. We should be following what our dentists and doctors tell us. And our security teams tell us, but it's still hard to kind of wrap your head around sometimes. So let's talk about what you can do as a developer. Like I said, boring advice, but you should really be doing it. First, figure out what your dependencies are. Now that can be kind of hard. If you're running on GitHub, there's a feature called Dependency Graph that lets you see these things. If you're a developer of a package, explicitly declare your dependencies. Consider using a lock file and keeping it updated. Next, and this is the step that everyone's too lazy to do, but remove your unnecessary dependencies, right? You don't have to patch something that you don't have. That's like the Zen art of patching. Don't patch things that are not in your environment. So for example, if you're using containers, use a scratch image or a minimal base image. That's a great way of getting rid of things that you don't actually need in your environment. Automate security updates. If you can, automatically pull in security fixes for your code, right? I know I said earlier in one of the examples, there are some cases where you might not want to do that. For example, if you're automatically then publishing or not having a human review anything that goes on. But this is so important. And if you take one to-do away from this talk, it's do this. If your testing isn't good enough that you feel okay automatically pushing security updates, then please pay close attention to security advisories, security advisory emails or alerts or Twitter or however you get your latest vulnerability information, and know that you can patch, right? Just because you're not patching on a regular basis, you want to make sure that you're actually using a recent enough version that you can apply a patch, like that the patch will come out for that version, and that it's not disruptive to your environment to actually apply that patch. Because if you have to do something urgently, you want to be able to do it. Testing out your patching and deployment pipeline, great activity to do in quarantines. Great thing you can go spend a couple hours on and see if you can patch something. And lastly, verify if and where you can what your dependencies are that you're using. If you're part of a big company, conduct your own audit. Publish the results in a way that's respectful to the maintainers. Run tools like npm audit to verify your packages before you pull them. Scan your code and packages for known vulnerabilities. Check the checksums of what you actually pulled to verify that that's what you expected. Check the signatures. Like do that check that you would want to be able to do to have trust in your environment, in your dependencies, in your code. So it's really boring advice. Remove what you don't need, patch what you do, and do it regularly. Patch. And if you're using GitHub, there's a couple features here that you can use to address some of these things. Security alerts notify you of vulnerabilities in code dependencies that you have. Automated security updates generate a PR to actually move you to a fixed version. Those are generated automatically when a new vulnerable dependency is found. And these work for various environments, various ecosystems, including Composer, Maven, NPM, NuGet, pip, and Ruby gems. Those features are on by default on public repos. Go turn it on for your private repos, please. And then lastly, to learn more, oops, I lost my screen. To learn more, there's a list here of some links you can go check out. The first one there is a list of supply chain compromises published by the Cloud Native Compute Foundation. And then I have some links to some features you should be enabling in your environment. That's it.
Hey, sorry about that. I was trying to reshare my screen to come back in and made a little silly mistake. So thank you so much. I thought that was really interesting to listen to. Security remains so important to all this, and one of the things that I really enjoyed hearing were about the supply chain attacks. Specifically, one of my favorite ones, obviously, is LeftPad, and it's not really even a supply chain attack if you think about it. It's simply almost in the same way that Seth from Google, when he removed his chef.
Seth had issues with who was using his package downstream. He was like,
"Yeah, and
I'll take this offline, right? And change licensing and things like that. Like I think developers can do these things for various reasons, right?"
Yeah, I love Seth, and I think one of the things that I got the most out of it is that sometimes you make decisions about the code that's used that you create, and it has repercussions, and sometimes those repercussions are to some's benefit, some's it's not quite as much, and so that's something that it's really interesting to learn about through how you can't just always be prepared for the obvious intrusion.
Agreed. And I think it's been really interesting. I've been looking at a lot of different supply chain attacks, focused on server attacks, I should say. There's also attacks to like put things in a Apple App Store app, or like into some piece of remote software that you'd use to like anyways. I'm looking at mostly on the server side, and it's interesting to see how often this is just caught by the community. Like the people who are finding this are people who are going, that looks weird. And we're really lucky when that happens within an hour or 2 hours or 4 hours of something weird happening, right? A lot of the time, though, it's people aren't paying attention because everybody has too much shit going on. So it's good to see people step up and pay attention where they can be paying attention, but we can't expect that to happen, right? We need to be able to verify this stuff, automate this stuff, so that we don't have to rely on humans to be doing this work for free.
That's really a great point, and I think that we don't sometimes think quite as deep when we start prepping. We think, a couple levels, but we like how many OSI layers we have in the stack. You sometimes have to think about all layers, and when you think about security, sometimes you have to peel it like an onion. Got to get through all the layers to make sure that you've really secured all aspects of not only your business, but the applications that come along with it. So, hey, Maya, you want to help me close the section of the evening?
Sure.
I'm going to put on, I like Run the Jewels. I'm a big fan of them. So let's.
This week on Yankee and the Brave.
Finish up the evening. Thank you so much, Maya. Another great talk in all of this. I really appreciate you being part of this. And is there anything you want to share about anything you're doing, or anybody you want to say a big thanks in all this to?
I think I'm just really excited for the entire community to put this on, and volunteers like yourself for making it happen. I'm really thankful for that.
Well, it's I like to use the word. I guess the word is dope. When I talk about opportunities like this is a dope opportunity, and so you're part of that opportunity. So thank you for giving me some of your time tonight.
Thank you. Have a good night.
Cheers.